Good morning, good afternoon, or good evening, depending upon where you live around the world. This is just a wee bit of an update, and I thought I'd throw this into the mix. I'd made mention in a previous video, as I often start my videos with that idea, that a passing comment had been made that may need a little bit more fleshing out. I said that I wanted, in theory, at this stage, to make all my holes at the same height on all of the struts, but locate them very accurately around the circumference, and how I was going to attempt that. And it was this little thingy here, which I'll just lift up a bit, and that is taken directly off of the underlying honeycomb or wireframe structure, this thing here, which I have said is very, very crucial to the development of the approach that I'm making, because it gives a standard and a reference as we go through on so many different things, and so too now. But anyway, I created this little diagram that gave me the angles between each of the lines, which I could then use to scribe down the surface of the hub. But it's not the angles that was going to help me. It was actually being able to print this thing out, doesn't matter what size, and then laying it over my hub and trimming it to size. Yes, it would be good to be able to draw a 57mm radius circle, which you can do, but it's printing it out at 100% accuracy might be a wee bit demanding. We'll see. People that use printers more than I, because I don't use mine a heck of a lot, most of my stuff's done electronically, there has been in the past issues of getting it exactly right. But anyway, I digress. That probably just shows just how old I am. Anyway, print it out, doesn't matter, print it out oversize, lay it on your, or lay your hub on the drawing of the, the printout, and then scribe onto your hub, your steel hub, where the positions are. That is 100% accurate. Don't go by the angles at all. That may be handy for when you make cuts in your timber, but for this particular exercise, having a printout for each of the individual hubs, very easy to do, and I would say, yeah, it increases your chance of getting it accurate. Maybe put some registration marks out at the at different measurements out from the center, so that you can better lay it on. Perhaps put some concentric rings, print some, in a few millimeter increments out around this area here, so that you can better register your hub to it, because after all, your hub may not be exactly the diameter of 57mm. It should be for my purposes, but so that's how I was approaching that little issue. Simple and accurate. As part of the drawing exercise, however, I decided to go through and extract the different hubs, as we see here, and create the model of them with the holes penetrated through them. And as you can see, there are 7 different hubs in the design. These are a left and right version of each other, so you could produce it by one, but nonetheless, there's 7 different hubs requiring this pattern to be created. And knowing that, I can now focus my resources, when it comes time of course, to doing these 7 patterns take them out and pop them on the hubs and scribe away and get my correct hole positioning. But one of the things, and perhaps the main benefit of this video, is this little thing here. And I created this showing where the heights of the dowels or the screws go through, and it just happens to be it's 15 millimeters up and then 50 millimeters up from that line, and I made this little grouping of lines so that I could generate it onto my models. Also, for accuracy purposes and from a prior video, if you go to do that within SketchUp, take it to the center of your model, which you should perhaps have a line at, and then move it out in this case 57 millimeters, to ensure you do not move this grouping of crosses or center points onto the surface of this model, because the surface of the model, as we have found, and the correct distance out need not necessarily be the same, and is unlikely to be the same. And that's an important thing for us not to trip ourselves up on. And we found that the distance that it's out is so small, it's easy to think that it's in the correct place, but it's not. And even though it very likely won't cause much of a problem, I have found it doing so in some specific instances. And the difference between on the surface and in the correct place can be as small as 50 thousandths of a millimeter. Now, I know that if at first hearing you think, well, that's just pathetically, it's just being too prissy about the measurements. Well, no, it's not, because as you rotate and manipulate, you can compound and exaggerate that tiny little measurement where it does become an issue. Not much of one, to be fair, but it is one. And if we can eradicate those little issues, well, why not? So just an example, what I'm saying is that if you take this model, put it at this point here, which is the geometric center of the hub, and then I can move it out, in this case in the green axis, 57 millimeters, which I will type in, it puts it in the correct position. And as we zoom in, this one will, and this is why you will be tricked into thinking it's not an issue. You will think it's in the right place because it's right on the line. Well, yes it is, because this circle, this circle on the outer edge of the hub is at 90 degrees to the axis, so therefore this point is correct on the surface. But as we can see, the little lines as they change angle, if that had been placed here, or there was an odd number of lines and the flat of the circle was around here, you would have not have been in the right place. I'll delete that, and we'll see where as we can see here, we're ever so slightly off the the point of transition between this flat and this flat of the circle, and with this tiniest little amount off. Had it been more into the center, more so. So I know it's one of those, it's important to me, so it's the only person that matters type thing. Well, no, it's not, because I've found it irksome in other areas. And it was the same thing about when we scale things. Sometimes we may scale as a percentage or a fraction, as is the scaling tool, or we can scale to a measurement. And scaling to a measurement often gives you better results that later on don't trip you up. And I have found scaling to a percentage can create that very inaccuracy that you think doesn't even exist, and you have problems. and especially when you scale at an odd, no, that's not, it's probably not, you have to be very careful wording that, because a lot of the fractions of, as you're scaling, will give you an exact measurement. But just as in this case, if I place my little set of crosses at the, I'm going to say inopportune, but the most opportune point, it will give you a reading that you think is 100%, and it was in this case. But in all other cases, it's not. So, if I'm not convincing you, sorry, because I wished I had done a better job. If I have already convinced you, this will sound boring, and I also apologise for that. So, but it's one of those things that once you've experienced the issue, you can't go backwards from it. And I've been caught out in those two instances, and I'm thinking, well, that's a lesson learned. If I can pass it on and it is taken up by other people, hopefully they'll benefit in the same manner that I did. And if not, well, c'est la vie. Let's just get on and make some more models. Yay. So I'm now going to create the penetrations in these models. I will place them back into the dome. Well, that's another thing. Padding it out a little bit, but again, it's one of the benefits of having this conglomeration of lines and surfaces. I try and orientate all of my models that I'm building up to the X, Y, Z, or the red, green, blue axes of SketchUp. You can't do that easily when taking them from in place, because then once you, for instance, if I put a line there, I'll just show you what I was doing. The line there, each of them is 100 mils long. Of course, you can't see it at the moment because it's overlaying the model itself. So I've put those 4 lines in there, and I group them. They don't have the grouping in the natural, well, it does actually, but the model itself, the 4 lines, don't align to the red, green, blue axes. So what I've done, unhide, I select that, and I will rotate it, hopefully correctly. See, from there, nope, I'm not rotating it around the correct line. Okay, rotating it through that line, I can take it up to there, which is in the correct place for the red, green, blue axes, explode it, and then regroup it. Now it is in the correct orientation. I'll get rid of that. Now it is in the correct orientation to the red, green, blue axes. I can take that model, place it down into this area here, and I can create these models here, because that's one of them. Much easier to manipulate, especially when you and this is the trouble too, when you start grouping them. Like now I've got a disc, I've got these crosses, and I've got these radial lines, and that's just the beginning of the project. If I group those together, they relate to the native red, green, blue axes. I can pop it up into the model, and it's already grouped, and I can manipulate it so much easier, add things much easier than when it's not grouped in that manner. And the trouble is, quite often we'll add something in place, and that will change that capability or facility. Again, you've probably, if you listen to that and go, well, I don't think it really makes much difference, well, then it's fine. It doesn't make a difference. You're not being impeded by it. But I found that the ability to have your model as much as possible orientated to the natural program's axes is beneficial. So yes, there's another one. That's a third point that may be of benefit to those that are finding a problem. Those that aren't finding it a problem, just carry on. Okay, that's it. I will leave it at that, and I will get outside and do some work that's a bit more productive before winter starts to raise its, well, autumn and winter raises its ugly head here. Rightio, I'll see you in the next one. Bye now.